Okay, welcome, Dominique, Thomas, Mario. This is the week 7 webinar, and we have a bit to do today. We're going to be talking about chapter 9, which is hypothesis test for a single population mean and a hypothesis test for a single population proportion. So it's kind of similar to confidence intervals, except that confidence intervals estimate and give a range of values. Hypothesis testing is for making decisions. So you look at the data and you decide you're going to do it or you're not going to do it based on looking at the data. And we'll talk about that, what that means. I'm also going to spend a little bit of time talking about the exam, because you do have an exam coming up. And the midterm is high stakes, lots of points. Take it very seriously. Okay, that's just a note. So that's the plan. I might talk a little about the project also. So again, we got one deep chapter, and then I'll talk about a few things. So before I start, are there any questions from any of you? Any questions? I guess I should look at the chat. No, there's nothing in the chat. Okay, if there's no questions, I think I'm going to share my desktop, and we're going to look at the good thing I love about this class is I can just go online and find stuff in the news or whatever that relates to what we're doing. So let's do that. Okay, so here's an article that I read in the news today. And what it says, let me make it a little bigger. It's a little sad, actually, at least in my opinion. The field for vaccines falls. So, there's some controversy about vaccines. There's no scientific controversy. It's only political controversy, unfortunately. Or not even political, it's more, I don't know, people, it's kind of like the flat earth. There's some people think the earth isn't round, but we all know it is. So vaccines are the same way. So let me read the article a bit. And it says the number of Americans who believe vaccines are crucial to public health has fallen by 10% in the last 10 years, according to a new survey. A poll for Research America found that 70% say vaccinations for diseases like measles and polio are very important. That number is down from 80% in November 2008, who said the vaccines are crucial. So just a note, I'm not going to read the whole thing, but I will read a little bit. And they conducted a nationwide poll of 1,004 individuals this month. And then the survey's margin of error is 3.1 percentage points. Now, we understand margin of error from last week. So that would be if you wanted to construct a confidence interval. That'd be pretty easy now because, again, we're at 70%, but then there's a margin of error of 3%, and you can go down and up that, and you get like 67% to 73% would be the confidence interval for the percentage of all Americans who think that vaccines are crucial for public health, I think it says, something like that. Public health. Does that make sense? That was last week's stuff. All right, so now we're going to do this week's. So let me write down. I forgot to write. Let me write down the crucial numbers because we're going to have to stick them in the calculator. So the first one is that our study found that 70% say that vaccines are important. What is that 70%? What is a symbol? What do you call that? Either in symbol and words in our class.
Is it proportion?
Yeah, which proportion is it?
P. P hat?
No.
Oh.
So it's p hat.
Okay.
Yeah, it's p hat because it's a sample proportion. Does that make sense?
I thought it was population.
No, it's definitely a sample. There's no way in the world I can guarantee. We know actually they said that they asked 1,004 individuals. Okay, I know 100% certain that they don't know how everyone feels. The reason I know 100% certain is they didn't ask me. So they don't know how I feel. And my guess they didn't ask any of you either, did they? In my career, I've never had anyone say, yes, oh, they asked me that one. So no, this is definitely a sample proportion. So p hat equals 0.7. Okay. The sample size is 1,004. What letter is that?
N.
Yeah. So n is 1,004. The other thing we need is that what it used to be, and we're going to assume that they just know what it was 80%. Okay, that we could think of as a population proportion. We want to say, well, is the population, has it really fallen from 80%? Or maybe this is just sampling error. Does that make sense? Maybe it really is 80%, but they asked 1,000 people, they got 70%, and that's just sampling error because you're not going to get exactly the same thing as what the population is, right? That's true of any sample. So that actually is going to be P naught, and that's 0.8. Any questions about these important things? Okay, so now I'm going to reshare my desktop and we're going to start writing. Okay, so the first thing I want to do is I want to write down what's called the null hypothesis. So there is an order at which you do hypothesis testing. The first thing you do is decide on what the null and alternative hypotheses are. The null hypothesis is basically what kind of the status quo is. And in this case, the null hypothesis, let's change that number. 20 is probably good. We call it H naught. The British got to it before the Americans did, so we use 0, they use naught for that number. So we blew it. Okay, so H naught, and that is P is equal to 0.8. So the null hypothesis is kind of what you're trying to show is not true. Okay, last time they looked, it was 80%. We think it has gone down. Any questions on that idea? Okay, and H stands for hypothesis. I want to note a few things. First is after that 0, there's a colon. That's not an equal sign, that's a colon. So you need to get this notation down. And then either you can have a P or you can have a mu. In this case, it's P because the survey question is a yes-no question, right? Do you think that vaccinations are crucial for American health? Okay. And then we're going to have what's called the alternative hypothesis. And that is labeled as H1. It's usually a subscript 1, but I can't do subscripts on this section. So, and that is going to be P. It's what we think is true. What do we think is true? Based on the article. Any thoughts?
P is less than?
Yeah, P is less than 0.8. So the idea is H naught is going to have equals, and H1 will either have less than, it'll have greater than, or it'll have not equal to. Those are the 3 possible inequalities you can end up with for the chapter 9 stuff. P is less than 0.8. Any questions on that? Okay, the next thing you usually want to do is think about what's called a type 1 error and a type 2 error. So a type 1 error means that after doing the study, we're gonna say that H1 is correct. We're gonna say there's evidence to show that H1 is correct, but it's an error, meaning that we were saying that H1 is correct, but actually H naught was correct. So now let's think about this in words, and let me write this in words. Type 1 error. Type 1 error means that we accept that fewer than 80% think that vaccines are important, crucial for public health, but I'm just making it shorter. When in fact, the proportion is 80%. Any questions on that, what a type 1 error is? So, you know, that's an error because we made a conclusion and then our conclusion's wrong. Okay. So notice that if this happened, then you're going to end up thinking that fewer than 80%, which means it's going down. And then, for example, if you're in the medical field, you're going to realize that you better spend a lot of money doing public notices to get people to understand vaccinations. Does that make sense? But in fact, we didn't have any problem. It's not going down. So you wasted your money in the advertisements or in the education. Does that make sense? So that is called the ramifications or the repercussions of a type 1 error. So we end up wasting money, wasting time and money on public education when there were no real issues. Any questions on type 1 error? Okay, I bet you can guess what I'm about to talk about next. What do you think?
Type 2 error.
Type 2 error, that should be obvious, right? So type 2 error. So two things could happen. One thing that could happen is a type 1 error. Okay, and that means, again, you made the conclusion that it did go down, but it really didn't go down. Type 2 error is the opposite kind of error. And that is you weren't able to make the conclusion that it went down, but it did go down. So let's write this down. And it's called failed to reject. That the 80% think they're important. Okay, but fewer than 80% think they're important. Okay, so in that case, what would happen, you think about it, that would mean that we weren't able to show that there's a problem. We weren't able to show that there's been a decline in the understanding of vaccinations and how important they are. But there really was a decline. Okay, so the ramifications here are that we're not going to put in money for advertising campaign to help people understand vaccinations, but you really needed to. So what's going to end up happening is more and more people will not understand that vaccinations are crucial. Okay. And what do you think? What bad things will happen then?
People won't get vaccinated.
Yeah, and then they're going to die of polio. Okay, and many people will get polio and other bad diseases unnecessarily. Okay. So you're just like confidence levels. In confidence level, remember what the standard confidence level was? What percent was a standard confidence level?
Is it 95?
Yeah, it was 95%. It's an interesting thing about hypothesis testing. In confidence intervals, for some reason, and I have no idea why, you advertise the percent that you're right. With hypothesis testing, for some reason, you advertise the percent that you're wrong. So any guess on what the standard, what we call level of significance is for hypothesis testing?
5%?
5%. Yeah, because it's the other side of the coin. Does that make sense? So 5% is standard. If the type 1 error is worse than the type 2 error, you typically then you want to make sure you have a smaller level of significance. Because you really don't want to blow it. If the type 2 error is worse than a type 1 error, then you want a higher level of significance. Because then it's okay if you're wrong, you just want to be able to show that it's true. And if you showed it but it wasn't really true, then it's not as bad than if you weren't able to show it. Okay, which do you think is worse, type 1 or type 2 in this particular case? Or are they about the same?
Type 2 is worse.
Yeah, I think type 2 is worse. Okay. By the way, if you're one of those anti-vaxxers, first thing is you should learn science. Second, then you would probably think type 1 is worse. But really, you should learn science. Okay, and statistics, by the way. Every statistical study shows that vaccination is safe and really important. Okay, so type 2 error is worse, and if type 2 error is worse, instead of using a 5% level of significance, we're going to use a 10%. Any questions on that? So what I'm going to do is I am going to go ahead and write down the level of significance. And the letter we use is an alpha. It's the first letter of the Greek alphabet. And in this case, alpha is going to be 0.1. Any questions on that? So it's another Greek letter, just like pi is a Greek letter, and mu and sigma. Alpha is another one. Okay, and it's the one that everyone uses for level of significance. Is that clear so far? Okay, so again, there's an order in which you do things. The first thing you do is decide your null and alternative hypotheses based on what you're interested in studying. The second thing is you think about what a type 1 and type 2 error are and what their ramifications are. Then you say which is worse, and then depending on that, you're going to choose 0.01 if the type 1 error is worse. You're going to pick 0.05 if they're about the same, and you're going to pick 0.1 if the type 2 error is worse. And if they're both really horrible, then you use a big sample size, and that lowers both of them. But typically, with the same sample size, if you raise one, you lower the other. If you lower the one, you raise the other. It's a give and take. You can't lower them both without a bigger sample size. Any questions on that? Okay, and now you should be used to this. What's the next thing we always do? What's one of the main things we do in this class when we have data like this? What do?
We draw a picture.
You draw a picture? That happens sometimes. So let me draw a picture just for fun. And we go to our calculator. But let me draw a picture because I think that's a good thing. And I got my pen ready. And I hope you all know what the picture looks like. Notice we can draw a normal distribution because if you take 1,004 and multiply it by 0.8, you get around 200 or so, which is, about 800, which is much bigger than 5. And if you take 1,004 and you multiply it by 0.2, then you get around 200, and that's much bigger than 5 also. And remember, if NP and NQ are bigger than 5, then you have a normal distribution. So we're going to draw a picture, and what we're going to do is we're going to say the following. Okay, 0.8 is what's called the hypothesized proportion. Okay, then we're going to say, well, first thing we have what's called a left tail test, which is less than. Less than is on the left side of the x-axis, right? Hopefully you all know that from basic math, right? So on the left, I'm going to shade in so that the area shaded is 0.1. And what's going to happen is if our value that we get, okay, so we got 0.7, if 0.7 happens to be here, if that's 0.7, then we're going to say it's not far enough away from 0.8 to be able to say we have evidence. If 0.7 were over here, then we're going to say it is far enough because it'd be very rare to get something over here, and we're defining rare by this 0.1. So then we're going to be able to say we have evidence. Okay? The value that we get, that area that we get to the left of our observed value is called the p-value. And that's what the calculator is going to give us. The value on the x-axis, and actually the value on the normalized axis, so the z-axis, will be called the test statistic. And in this case, it's going to be normal because of the central limit theorem for proportions. So the test statistic will be z, z for normal. Any questions on that? Anyone lost on the picture, or do you see what's happening? Okay, so now we can go ahead and go to our calculator. So let me do new share. And let's pop out the calculator. And what I'm going to do is I'm going to go to stat. You're used to that. We're going to go to tests. Okay, and now last week we did confidence intervals. And on the calculator it was int, or interval, right? Today we're doing hypothesis tests. So instead of int or intervals, what do you think it's going to say? What?
Test.
Test. Okay. The good thing about those people in Texas, the Texas Instruments people, they were nice and they tried to really make it easy to read. So it's going to be a test. Notice this was a yes or no question. So we're talking about proportions. And we only had one survey question, right? The survey question is, do you think vaccines are crucial for American health? So it's one prop Z test. Any questions on that? So then I go ahead and hit enter. It's going to ask us for our data. So our P naught, we said was 0.8. Okay, our X, we do a little bit of work because they actually didn't give you X. So I'm just going to quickly stick it in my calculator. X is going to be 70% of 1,004. 0.7 times 1004, and that's a 703. Anyone, any questions on that? N is 1,004, because that was a sample size. Notice it gives you a choice, not equal to, less than, or greater than. And that's why at the very beginning, we wrote down what our alternative hypothesis was, and that was less than. Do you remember? So we're going to go ahead and we're going to go less than and hit enter. Okay, it turns out it already said less than, but I just wanted to show you what you normally do. Color really is meaningless. And then I'm going to go to calculate and hit enter. Any questions before I hit enter and it leaves the screen? Any questions? Okay, let me hit enter. All right, so we have interesting data. The real world is different sometimes than like a test world. I probably wouldn't give you one exactly like this because the p-value is just way small. So first thing, z is negative 7.9. Now, you know from the normal distribution, we're almost 8 standard deviations away. That's like impossible, right? That's so far away that there's no way that the assumptions could have been right. And the assumption was that the proportion is still 0.8. And that's what we're going to be saying is wrong. We're going to be able to say the proportion is less than 0.8 because this is so far to the left, the proportion must have changed. Do you see that? That's the whole purpose of hypothesis testing. P-value, they round it to 0. It's so small, it just goes to 0. Just to let you know, on the midterm, I won't give you one that's exactly 0. Okay, so on tests, that's a little too hard to understand because it's actually not exactly 0, but it's so close to 0, it rounds to 0. P-hat was the 0.7. We knew that because that's what we figured out. And then n was 1,004. Again, that was just given. Any questions on this? So again, negative 7.9. Let me go back to here. So now we can say our test statistic was z is equal to negative 7.9. It's off the chart. It's so small. The p-value was equal to 0, which is also off the chart. Okay, it's not truly equal 0, but there's probably 50 zeros, and then you get a 4 or something after the decimal place. Any questions so far? Okay, what I want to do, I'm going to have to erase this for just space reasons. So if you don't want to erase it, you better tell me soon. Ah, lost it. And I want to write down the conclusion. So the important thing is that note that p, which is equal to 0 in this case, is less than 0.1, which was our level of significance. And because of that, here's the conclusion. And the wording's important. You do need to learn this wording. There is statistically significant evidence to conclude that the proportion of all Americans, notice not just the one surveyed, now we're talking about the entire country, who think that vaccines are crucial, is smaller than 80%. Any questions on that?
So you say it's statistically significant because the p-value is less than the
Level of significance.
level of significance. Okay.
Exactly. Okay, and by the way, if the p-value instead of 0, what if we had gotten, say, p equals 0.35? What would change here? 2 letters, that's a hint. You'd add 2 letters in. I guess. So instead of saying there is statistically significant evidence, you would say there is statistically insignificant evidence. And then the rest would be the same. So statistically insignificant means that you can't make the conclusion. You don't have evidence to make the conclusion. Statistically significant evidence means you do have evidence to make the conclusion. Just note, if we had gotten 0.35, we don't say that the proportion is 0.8. That you never do. So you never conclude H naught is true. You never say you were wrong. It's one of those weird things in life. Never admit you're wrong. Only admit that you're just not sure. And that's how statistics works. A little weird, isn't it? But you can't admit you're right, okay? Or at least you say you have statistically significant evidence to say you're right. Is that clear? Sometimes when you get such a low p-value, which we got tiny, tiny, tiny p-value, we'll say there's strong statistically significant evidence. And that like is bragging about it, you know, saying how clear it is. And you'll use the word strong before that if the p-value is really tiny like what we got. Any questions on that? Okay, I just want to talk about the p-value and what it means. So now let me write down interpreting the p-value. And what that says is that if 80% of all Americans, notice the word all, by the way, just like with confidence intervals, we're talking about the entire country, not about the sample. If 80% of all Americans think that vaccines are crucial, and if we conducted another study of 1,004 Americans, then there would be A. And the p-value was about 0, so 0%. Again, on a test, I wouldn't give you one to 0. You might have like 4% or something like that, or 2% or 12%. So this one's, you know, real life, sometimes you'll get the 0. There would be a, in fact, I'm not gonna write 0, there would be a close to 0. Even though the calculator shows 0, but it really means close to 0, because it rounded. Chance that at fewer, let's see, how many do we get? We had 700 and, let me go grab the numbers again. Let's see. Oh, that was over here, just a minute. 703 of them would, at most, (703) of them would think that vaccines are crucial. Any questions on that? Okay, so what it says is that our study was so unusual, right? There's almost a 0% chance to get our results or results as extreme as what we got, that something's up, big red flag. And hypothesis testing is all about raising the red flag. Any questions on that?
If the p-value on the calculator after running the test was like 0.02 or something, is that, so then you have to convert it to percentage, right? It's not already in percent?
That'd be 2%.
Okay, so
Right.
when you say then there'd be a close to 2% chance.
Yeah.
Okay.
And I think it's the easiest to convert to percents when you're writing this interpretation.
Okay,
Then
as
to
opposed to
keep it-
saying like 0.02.
Probability.
Yeah, okay.
You could say 0.02 probability, but I think it's easier to understand by talking about percent chance. Don't you guys think so? It's up to you, but I think it's easier that way. I know you got to move the decimal twice. You have to do that still. But I think it makes more sense when you read it. Any questions on this? Okay, a couple things. One, just like confidence intervals, there's no short way of interpreting the p-value. Just like there was no short way of interpreting the level of significance. It's going to be a long sentence. You remember that with confidence intervals? They were long sentences too. So don't think you can do it in a shorter way. Okay, so that's one thing. Notice also that this 80% is all Americans. This 703 is out of the sample. Okay, you could also say that there'd be close to 0% chance that at most 70% of them, of those 1,004 Americans, would think vaccines are crucial. That's the same thing. Any questions on that? Okay, I want to do one more interpretation. Let's do it in green. Just want to pick different colors for each one of these. I'm not sure if I have enough space for it. All right, so now we're going to interpret the level of significance. So it starts exactly the same. If 80% of all Americans think that vaccines are crucial, and if we conducted another study of 1,004 Americans, then there would be a 10% chance, because we decided 10% was our level of significance. So now I'm going to interpret the level of significance. That, and now I got to start thinking. Okay, so far it's been exactly the same except for the percent chance. So what the level of significance is the probability of a type 1 error. And type 1 error means that the null hypothesis is correct, 80% think that vaccines are crucial, but we end up saying that fewer than 80% are. So that we would end up falsely concluding that fewer than 80% of all Americans think that vaccines are crucial. Sorry if it bled on the other stuff, but hopefully you can still read it after hearing what I said. Any questions on this?
So you get the level of significance by like interpreting the type 1 and type 2 errors, right?
Yeah, so let me tell you, there's two ways you get it. One will be really easy, and that is if you're doing an assignment on the homework or taking a test, it'll just be given to you. Does that make sense? But on your projects, you're going to have to decide.
Okay.
And you're going to decide based on the type 1 and type 2 error. So in the real world, there are two ways of deciding. One is decide versus type 1 and type 2 error. And I'm telling you based on my experience doing consulting doing statistical consulting. The other is because your client tells you what it should be. And that happens sometimes. Okay, sometimes the person, the client who's paying you is going to say, I need it to be 5%. Okay, 5% is standard. 5% is standard. You only go up and down if there's issues with the type 1 or type 2 error. Is that clear? If there's kind of an imbalance of issues is really what I mean. There's always issues, but if there's an imbalance of issues, then you will go up or down depending on what how the balance is. Any questions on that? Notice at this point, since we rejected the null hypothesis, you don't have to worry about a type 2 error anymore, because a type 2 error is when you fail to reject and then you were wrong. So here, there's only a chance of a type 1 error at this point. So before you can conduct the study, either type 1 or type 2 error could happen. After you conduct the study, only one of them can happen, depending on whether you rejected or failed to reject. Does that make sense? Any questions on that? Okay, so that's pretty important to note. I'm not going to go over lots of examples. There are lots of examples in the chapter video, because I do want to make sure I have time to talk about the exam and the project a bit too. But I want to let you know that the example I did here, this pretty much covers every kind of example that involves proportions. If we were to do something that was quantitative, then how would that change in terms of H0 and H1? So if we wanted to find out if people get less than 8 hours of sleep a night on average, what would change in the H0 and H1?
Would use the mean.
Yeah, what letter would you use? It is not P. Mu. Yeah, we'd use mu instead of P. Does that make sense? I want to note something else that you won't even notice and you won't even think about, but I want to emphasize it so that it keeps in your mind later. And that is, if you look at H0 and H1, there's no words in there. Do you see that? So if you're doing a chapter 9 question, you're not allowed to have words in the null hypothesis and alternative hypothesis statement. Later you can explain it, but you got to have it in symbols. Is that clear? That's very hard for students. And I know it's hard because it's hard for me because I have to be real sad as I'm taking off lots of points off your tests. And the reason why it's hard is in chapter 11, it's all words. So that's going to be a challenge for you, is to keep track of when you have words and when you have symbols. So if you're in something from chapter 9, it's symbols. Got it? Okay, or you'll lose points, by the way. And I don't like taking off points, but I have to. Okay, any questions on this? Okay, the other thing is this was a left tail test because it had the less than. And because we had the less than, then if you look at the conclusion, we have the word smaller than. Do you see that? Okay, and similarly, if you look at the p-value, we had at most, which is smaller than, right? So everything goes with that less than. Had it been greater than 0.8 instead of smaller than, what do you think you would have had?
Greater than?
Greater than. Okay, and you wouldn't have at most, you'd have at least. Is that clear? Okay, so you got to pay attention to that. Then there's a third one, and that would be not equal to. So instead of smaller than, what words might you have? If it was a not equal to sign. Should I tell you?
Is not 80%?
Good. Is not 80%. There's a lot of ways of wording it. Is not 80% or differs from 80% is another way of wording the same thing. But look for those words in the question on the test, for example. Okay? They'll be there. There'll be something that either talks about smaller, greater than, different, and that will help you decide what the inequality is. Is that clear? Okay, so you need to look for the words. If it were a two-tailed test, then you would have to do the following. Okay? So then you would say that you would have either fewer than 70% or more than 90%. How did I get the 90%?
One minus 10%.
Yeah.
Or 1 minus 0.1.
It's not quite like that. So let me explain. So that the 70% is 10% less than the 80%. So in the picture, let me draw a picture. And you know what I'm about to draw because the picture is always the same. With a two-tailed test, we draw both sides, right? So had this been 0.8, this was the 0.7, which is what we got, right? That was our value that we got, our proportion.
Would it just be times 2 because there's 2 tails?
Yeah, there's 2 tails. So notice that 0.8 is 10%, 0.7 is 10% less than 0.8. If you draw the symmetric picture, you go 10% above 0.8, and that's 0.9. That's always a tough one for everybody. Anyone lost on how I got that 0.9? So it's a symmetric picture. So then you would say it's either less than 70% or greater than 90% for the interpreting the p-value.
And is the 0.8 and the 0.7 and 0.9, is that the area underneath? Or
no, those are values of, those are p's, p-hats actually.
Oh, okay. So those are like values on the...
Yeah, the area is the p-value.
Okay.
Which is 0 in this case.
So
or close to 0.
That line was so far to the left that the area was practically 0?
Right. And as I said, for testing, I won't give you one that goes that's close to 0. And in fact, on the assignments, because remember, I programmed all this stuff, is that I programmed it so that p isn't going to be 0 on you. Okay, it might be 0.0003 or something, but it won't be 0. Got it? Okay, but in the real world, sometimes p is never exactly 0 because the normal curve goes forever, right? But sometimes it's so close to 0 the calculator tells you 0. Does that make sense? Okay, so I want to make a note about the project. Okay, you're almost ready to really think serious about the project. Okay, part of the project is confidence intervals. We talked about that last week. Any guess on what the other part of the project is?
Hypothesis testing.
Hypothesis testing, because that's this week. Okay, so you're going to have to conduct a hypothesis test. And really, that's where you start. You don't start with the confidence interval. You start with H0 and H1. Because you can't get a confidence interval until you collect the data. But you can write down H0 and H1 before you write that down before you collect the data. And you must write it down before you collect the data. Okay, and I don't know if you remember, for some of you, it might have been like a few months that you were in 8th grade. How long ago it was? Just kidding. But it was a while ago for some of you. You learned something called the scientific method. Do you remember that in 8th grade? That's an 8th grade standard. And this is a scientific method, if you think about it, right? It's the steps in scientific method. You write down your hypotheses, then you run the experiment, and then you analyze your numbers, and then you make your conclusion. Isn't that the scientific method? So this is the scientific method. So you've seen it before, just not in a statistical context. You've seen it in a scientific concept. And some of you might have forgotten what you did in 8th grade, but you do that, it's standard in 8th grade. It's a big piece of 8th grade. Sometimes 7th grade too, but definitely 8th grade. Do any remember that, doing it? Some people don't remember anything in middle school. Okay, and you might have done it later too. So in your project, you're going to have to conduct a hypothesis test. What you're not ready for, but I'm going to say it anyway because it's next week's stuff, but some of you, I know, Dominic, you want to start thinking about your project. So first thing, it's going to have to be quantitative. And the reason, now that we're in project 2, you should understand why you don't want to do a yes-no question. How many people do you have to survey if you have a yes-no question? Remember, the ballpark figures typically are around what? The hint is it's up on the screen. See it?
1,000?
Yeah, around 1,000. And do you really want to do 1,000, get 1,000 data points? That'd be horrible, wouldn't it? Okay. On the other hand, if you're doing a quantitative study, then if you do say 35, that's just fine. But for the yes/no question, you need much bigger sample sizes to have any kind of good data. For the quantitative, you don't need such a big sample size. So I'm making you do quantitative because it's easier, not because I'm being mean or something. So you don't have to do 1,000. So the other thing, and this is something you don't know how to do yet, but it's going to be a comparison study. So it's going to be very similar to this, except you can have 2 samples instead of 1 sample. And instead of a t-test is what the calculator has for 1 sample, you're going to have a 2-sample t-test. Or you're going to have a t-test with paired data, and that's next week. We'll talk about that. Okay, so just to note, you're not quite ready yet in terms of the knowledge, but you can start thinking about what you want to do a comparison of. The other thing is it doesn't have to be a survey. It could be any kind of data collection. You can go online and do the data collection on that. Okay, I know, Marielle, you're going to do data collection on the snapshot day that the 2 of us were at. That was fun, wasn't it?
Yes, it was. Always is.
Yeah, we collected data. This was my 18th year doing it. And we collected data as volunteer scientists, or scientist wannabes, I guess. And that's the kind of stuff you can use. You can use data that's out there, and that's okay. But one of the rules is that if you can get the entire population, it's not acceptable. It has to be something you can't get the entire population of. Because if you can get the whole population, there's no reason to ever do a confidence interval, because then you just know it. Does that make sense? There's no reason to do a hypothesis test. You just know the truth. Is that clear? Okay. I don't need to do a hypothesis test to find out the proportion of people that are here right now whose first name is in the first half of the alphabet. Why don't I need a hypothesis test for that? To say more than half are in the first half of the alphabet? Okay, because all I have to do is look at the names here. I got 5 of them, and we got Amberly, right? Mariella, we got Dominique, and myself, Larry. 4 out of 5. Hey, we got more than 50%. There's none of this type 1 or type 2 error. It's true. Do you see that? So if you can get the whole population, you don't do a hypothesis test. You just know. Does that make sense? So it has to be a population that is unattainable, and you're forced to do a sample. Is that clear? Okay, unlike Project 1, you don't have to worry about sampling technique. You just have to note what you're using, but you're allowed to use convenient sampling if you need to. Okay? And if you use convenient sampling, you should just admit to it in the project and talk about what might have gone wrong. Whereas in Project 1, I told you had to do free-member stratified or cluster. Here you do whatever works for you. Does that make sense? Okay, so it's a very different project. It's not focused on the data collection. It's focused on the confidence interval and hypothesis testing. Any questions on that? Okay, the other bit is standard error. So if the standard error is big, that'll increase the p-value, which is bad. You want a small p-value, right? If the standard error is small, then that'll decrease the p-value, or at least make the p-value more to the truth. So if it was exactly 80% in our example, then we had a very small standard error, then we would probably get something very, very close to 1 for the p-value. Okay, the truth is revealed. If the p-value is close to 0, then you were able to reject the null hypothesis. If the p-value is close to 1, then you say that you failed to reject and you could totally give up and don't even try again, because at this point, you're probably wrong in the first place and H0 was probably right. Does that make sense? You only say probably, you don't say for sure. So that's a standard error. Standard error is really important for project 2. It's the biggie. Okay. Any questions at all on project 2 before I move on and talk about the midterm? Okay. I will talk about project 2 more next week, because next week we'll actually have the 2 sample stuff. But I figured, I know, Dominic, you wanted to hear now, so I gave you a little bit of insight today. But I'll get into it. We'll have the information tomorrow. I mean, not tomorrow, next week. Okay, next I want to go and, just a minute. And let me do a new share and talk about the midterm. Okay, so just to let you know, this is the home screen. Did you notice the home screen changed? When you first click on the class now, you get a different screen than you used to. You don't see me anymore, or not me in front of the college. So what I did is I put it to the modules because that's kind of the most important. So I know we're in week 7, but the midterm is next week. So week 8 is what you want to look at when you're studying for the midterm. So I put a bunch of stuff to help you for the midterm. Hopefully it'll help you. And it's all in the week 8 module. Any questions on that? Okay, so a couple things. First, the rules of the midterm. The rules of the midterm are you get a note card, a 3x5 note card, and you can put anything you want on that note card. And you can write in the front and you can write in the back. So some things are going to be clear that you want, and that is there's some formulas like remember there were sample size formulas that were a bit messy? Do you remember that? There was also like the mean and standard deviation of the uniform distribution. That was a bit messy. So some of the formulas that the calculator doesn't have, those you probably want to put on a note card. Other people find putting examples on a note card a good idea, that will help. Okay. So the note card is totally up to you, though. Whatever's going to help you is what you should put on the note card. And I would start working on that pretty soon so that when you're studying for the test, you'll have the note card in front of you and it'll be like you're taking the regular test. Okay, the second thing is the number of hours for the test is 2 hours. Okay, if you have a disability, then that's adjusted. But for those who don't have a disability, it is a 2-hour test. Okay, and that will be strict. The proctor will make sure of that. The other thing is when you arrive at the proctor center, you must show a photo ID. Could be a driver's license, a passport, could be your photo student ID, but you have to have a photo ID because they're going to check your ID, make sure you are who you say you are, and then you can take the test. I do that to basically keep you from paying someone to take your test for you. I know that sounds horrible, but do you know how I know that happens? It's kind of sad.
Before?
Huh?
I said because it's probably happened before.
It hasn't because I make sure you check ID. Because I get offers. Just random people asking me to take their online test for them. Not in my class, of course. But they're taking an online test for a different stats class. And they ask me how much I'll charge. That's sick. Okay, so I have to stop that. And if I went in and took their test and showed the ID and it would say Amberly, I think they would hopefully notice that I'm not you with the photo ID. So that's why I have to do that. So it's kind of sad. Okay, and by the way, I don't take their money. I tell them, no, you need to take your own test. So that's just a note. So you get 2 hours. Here's one thing you definitely must take with you. This guy. Okay, if you do not have a calculator with you, then you will fail the test. Because there's a lot of problems, and you're used to that all the normal distribution stuff, all the confidence interval, what we're doing, what we just showed you today, all of that requires the calculator. Okay? And I recommend taking some spare batteries. It's one of those Murphy's Law things, is that the time the batteries are most likely to go dead is when the test is happening, right? And the calculator knows it. So take some spare batteries. That way, if your batteries die, you have some extras. So I recommend that because it's awful if your batteries die. Okay, so take your calculator. That's really important. I don't think I have to tell you, but take one of these guys too. This or one of these, pencil or pen. But that you know. Okay. That's really important. Just they've done statistics. They found out any guess. And they've done statistics to decide what the best thing to do in the half an hour before the test, if you've already eaten and gone to the restroom, by the way. Certainly don't want to have to go to the bathroom when you walk into the test. You know the best thing to do? They did a statistical study to find out. What do you guys do just before a test? What do you think? Huh?
Study?
Actually, that's one of the worst things to do.
Go on a jog.
Yeah, that's one of the best things to do. But a light jog. Don't kill yourself. Don't go on a marathon. But a light jog. I used to throw a Frisbee around when I was a student. But some kind of light exercise is a really good idea. Take a walk. That's a good thing. It doesn't have to be that strenuous. But something to clear your brain, take away the stress, and just kind of get yourself moving. And that's the best thing you can do. The studying definitely should happen, but that should happen the day before in a big way. Lots of hours. And if you're taking the evening, it should probably happen the morning of. Okay? But not the 30 minutes before. You get a note card, so you don't have to do the quick memorization. Okay? None of that, and that's not necessary. Okay? What you have to do is be in a clear state of mind. So make sure you've used the restroom, make sure you're not hungry, all that kind of stuff too. And make sure that you're relaxed as much as you can be. Any questions on that? Okay, so between now and when you take it, and so far I've had a few people tell me, and you need to tell me pretty soon, by the way. The problem is that I've written the test already. I'm going to start sending it out later this week. But sometimes it takes a while for the proctor to open their email. Okay, and get the test ready, print it out and stuff like that. So tell me, by the end of the week for sure. And I don't mean Sunday, I mean like by early Friday. But even better is in the next couple days. And that way I can send it to the proctor. You can contact the proctor, make sure that they're ready for you, that they were able to open up the test, which I send in a Word file, but make sure that they can open it and print it out. Does that make sense? So that's your responsibility to make sure they're ready for you. My responsibility is to make sure I email it to them and I give them the instructions. Okay, so between now and then you want to do a lot of studying. So a couple things I have done. I want to show you the sketch of the midterm. I think that's probably the most valuable of all the tools to give you an idea of what this midterm is going to be. Okay? So what I have done is I wrote the midterm and then erased certain pieces of information that I didn't want you to see yet, so that you are not surprised when you get to the midterm. So these are the problems in order. So problem 1, for each part, okay, be sure to write down the sampling distribution for each. Put in your normal curve diagram, answer the question, and determine whether the normality assumption was needed. Okay? And then I say a scenario will be given, and then there will be a part A and a part B. Okay? I'm not giving you all the details, but I'm giving you enough. So in part A, how many things must you do? But I think I'm going to grab the test. There's the test, which, by the way, I'm not going to show you because this is actually the key. In part A, how many things must you do? read the instructions and tell me how many things it asks you to do. Four things. Okay, 4 things. Write down the sampling distribution for each. Okay, what does a sampling distribution look like? What do the symbols look like? Do you remember? I know it's been a while. This is chapters 6 and 7.
It's the X and then tilde and then parentheses and number, mean, and then standard deviation.
Yeah, although it may not be X to start.
Okay.
It's either going to be X, X bar, or capital sigma X. Do you remember that? So that notation, practice it. Promise me you practice it. You know it's going to be on the test because this is a test in my hand. That's the same. I double check it. It really does say that. Okay. Any questions on that? Okay. So, and part B, how many parts are there going to be to part B? It's supposed to be easy.
4.
4. A or B, it doesn't matter. They each have 4 parts. So there should be a total of 8 parts that you write. Okay, I don't know what to do to like tell you and make sure you do it because a lot of people just forget some parts. But I'm telling you, this is the test. If you don't have 8 parts, you can get lots of points taken off. Is that clear? Practice it. Practice it. And if you don't know how to do it, you practice a few. They're easy to make up, actually. And post on the Q&A forum, and I'll help you. Okay, on any of the 4 parts. The big formulas, if it's just a single item that you're picking, then it's just the mean and standard deviation. If it's a bunch of items and you're asked for an average, then it's going to be the mean and the standard deviation divided by the square root of n. If it's a bunch and you're asked for the total, then it's going to be the mean times n, and then the standard deviation times the square root of n. So there were different formulas for that. Okay, problem number 2. A scenario will be given. Okay, again, I'm not going to tell you the scenario, but there's going to be a scenario. And then I'm going to ask you to discuss the implications of a type 1 error. It's not define a type 1 error. Discussing the implications usually means who gets hurt and how does that pain happen. Does that make sense? Okay, what is the pain? And then B is discuss the implications of the type 2 error. Same idea. Who gets hurt and how does that pain happen? It'll be different for type 2 error. And then part 3, conduct a hypothesis test. Be sure to state the null and alternative hypotheses, the p-value, and the test you're using in your calculator. Then state your conclusion using a complete sentence in the context of the study. Just a note, when it says state your conclusion, what are the first few words? We did this today. That's why I'm hoping you might remember.
Is it there's statistically significant evidence or there's
exactly. Okay, so it'll either be statistically significant evidence or there is statistically insignificant evidence. Okay, so I'm telling you the first few words. Now I'm not going to tell you whether it's going to be significant or insignificant. That's going to be based on the scenario and the numbers in your calculator work. Does that make sense? But get that part right. I'm telling you. So I'm hoping everybody gets that part right. Just study hard. Practice, practice, practice. Any questions on this? Okay. Pay very close attention to whether it's quantitative or it's a yes/no question. So quantitative means you should have words like population mean, and yes/no, you should have words like percent or proportion. Does that make sense? So pay close attention to that. Okay, problem C. Please circle the following true or false. There are 8 questions. Okay, those are questions, and you've had lots of practice on the assignments that you've been doing weekly. Do you remember you've gotten a bunch of true falses in the last bunch of chapters? You notice that? So you're going to have true false questions. Okay. Just to note, when you're practicing number 2, you'll be able to go to the assignment, but it's going to do multiple choice on which is the right conclusion. Try not to look at A, B, C, and D, and try and get a pencil and paper out and write it out. And then look and match the one. Does that make sense? That's a better way of doing the weekly assignments, is to write it out and then look to see which of the 4 it is, instead of read the 4 and see which of the 4 it is. Because if you don't write it out, you're not getting practice writing. Okay, problem 4. Uniform distribution question. So let me ask you, what picture must you have? In one word.
The rectangle.
Exactly, rectangle. Okay, don't make it look like a normal distribution bell curve because it's a uniform. And I'm telling you now, number 4 is a uniform problem. Okay, and by the way, on problem 1, that's going to have a normal curve looking thing on the picture or the diagram. But problem 4 is a uniform distribution. 3 parts. One of the parts you're going to be needing material from chapter 4. So I do that in tests. It's a combination. Uniform, remember, was chapter 5. So you're going to have a uniform, but there's going to be stuff from chapter 4 asking about the uniform. Any questions on that? Okay, problem 5. It's going to be a question that involves statistics. For example, the mean, median, mode, standard deviation, z-score, interquartile range, etc. Okay, that was the first couple chapters. Remember that? So you're going to have to be understanding that the statistics that we did in chapter 2 especially, because that's where we did some stats. Any questions on that? Problem 6 is a confidence interval question. Okay, there are 4 parts. Okay, just a note, it actually, just so you're not confused, it actually on the real test says A, B, C, or D. It doesn't say 1, 2, 3, and 4. Hope that doesn't bother you. I doubt, no one's ever complained about that, but just let you know, the real test is not 1, 2, 3, 4, it's A, B, C, D, because it works better. And there are 4 parts to it. Determine the appropriate 95% confidence interval. Number 2, write a sentence that explains your findings. What are the first few words on number 2 for the answer? The findings of a confidence interval. It's only been a week, it's not too long.
With 95% confidence.
Good, good. With 95% confidence, we can conclude that. And then you write what you're concluding. Does that make sense? Okay. Number 3, use a sentence or 2 to explain what it means in the context of the study to be, actually, I wasn't going to tell you it's 95%, and that's why I put the XX, and then I made a mistake, and I told you. So it is going to be 95. 95% confident. Okay. That, if you remember, was if many studies were done, remember that? Then each would have its own confidence interval, right, etc. Make sure you do it in the context of the study. So that's where you can't just read your little note card. You have to put it, whatever that scenario is, you got to have stuff about that scenario. Does that make sense? Okay. And then number 4, was it necessary to make any assumptions about the underlying distribution of the population? Okay. That's the old, is the sample size large enough? If it's a quantitative question, what are you comparing with?
Has to have 31.
Yeah, 31 or bigger. Okay. If it's 31 or bigger, no assumptions needed. If it's less than 31, you need to assume that you have a normal distribution. If it's a yes-no question, what do you have to have?
Greater than 5.
Yeah, NP and NQ. So the number of yeses and the number of nos must both be greater than 5. Does that make sense? Okay, number 7. Another confidence interval question. This one asks you to find the sample size and then find and interpret the confidence interval. I want to remind you when it says interval that what are the first few words of interpreting the interval? Not a trick question.
Like we are 95% confident.
Good, good. Okay, don't write down if many studies were done. Okay, when you're interpreting the confidence interval, there's nothing about many studies. You just did your study. Does that make sense? I'll take off points, and usually about 40% of the class makes that mistake. So I'm telling you, don't make it, so please don't make it. Do you promise the 4 of you you're not going to make it? Right? The test isn't changing. This is the test. You're looking at it. Okay. All right, number 8. Okay. Oh, I also ask you, let's see, yeah, number 8. Let me get to it. And by the way, I didn't mention finding the sample size. Remember, there were 3 different formulas. N equals Z sigma over E quantity squared. N equals 0.25 times E over times Z over E quantity squared. And N equals P times 1 minus P times Z over E quantity squared. Do you need to memorize those? No, because you get a note card. But what you do need to know is which one to use when. So practice that. Make sure you know which one to use. Because you're going to be asked, you're only going to ask one of them, not all 3 of them. And you use the wrong formula, you'll get the wrong answer. Okay, problem 8. 8 is a hypothesis test question. So there's parts for number 8. First part, write down the appropriate null and alternative hypotheses. Find the test statistic and p-value for the study. Okay, I'm not going to spend much time on it because we just did that today, right? Then use a complete sentence to state the results. Okay, what are the words for that? How does it start?
They're statistically significant evidence?
Yeah, either statistically significant or statistically insignificant evidence. Okay. Number 3, the p-value represents a probability. Write a few sentences and interpret the probability in the context of the study. Okay, so that is if, and then you state the null hypothesis, whatever that is, not in symbols, in words. And if another study was done with that many individuals, then there would be a whatever % chance that we would get something as extreme as what we got. Okay, don't just write that. You have to do it in the context of the study, but that's kind of the idea. Then number 4, same thing with the level of significance. That starts the same way, is that if whatever the null hypothesis says was true, and if we did another study of that many individuals, then there would be a whatever % chance, and then we would end up falsely saying whatever the alternative hypothesis was. Any questions on that? We're almost done. Okay, number 9. Number 9, I give you a statistical chart. What are the main charts we had in the first few chapters?
Histogram,
Mm-hmm.
stem and leaf, box plot.
Mm-hmm. Those are the 3 main ones, right? You have to do on your project. Remember that? So I'm going to give you one, and then you're going to have to do a bunch of stuff. You're going to have to do some probability questions from chapter 3. And you're going to have to understand the standard deviation. Any questions on that? Okay, then there's extra credit. This is the only extra credit opportunity in the entire class. So do it, because anyone who writes anything gets full credit for the extra credit. So don't leave it blank, you promise? You could even start with that one, because there's no stress on it. This is what it is. Write down one thing your instructor, that's me, could do or have done for you to help you better succeed in the online class. Write down one thing that your instructor did for you that helped you succeed in the online course. And then number 3, write down one thing you could do for yourself to help you better succeed in this online course. And number 4 is write down one thing that you have done for yourself to help you better succeed in the online course. Okay? You don't have to write paragraphs on it. Don't take too much time on it. But you know what's coming, so just know what you're going to write before you even get there. Does that make sense? This isn't going to change. This is word for word. The only difference, as I mentioned from the rest, is it's A, B, C, and D instead of 1, 2, 3, and 4. But otherwise, it's truly word for word. Okay? And I give you more space, by the way, than this shows. Okay, and all the problems. Any questions on what to expect? You feel like you have a really good idea of what the test is going to be like now? Okay, because this is it. Okay, obviously, I haven't given you all the numbers and the details, but I've given you the structure of every problem. So I don't want the structure trying to figure things out, the issue. I want you to demonstrate that you know how to apply the concepts when you're not surprised about them. Does that make sense? Okay, but practice is everything. Don't just say, oh, I know how to do all that. I don't do anything. I'm ready. That's not true. You want to practice. Okay, just a couple more things before we call it a night. I know we're going a little over, but I always have to decide on this week whether I want to do 2 webinars or 1, and I've gone to longer one instead of 2 shorter ones. And again, that's something you could do on the X-Credit if you think you'd rather have 2 shorter ones, for the kind of review day. Then that'll help next quarter, next time I teach it. Okay, those are the kind of things that can help. And I do listen to y'all. So be careful what you ask for. You might get it. Just note, if I go back, okay, so I have a practice exam. That's a bunch of problems. These are not the same structure, but it gives you some more practice. And I'll let you click on it. It's just a bunch of problems to do. There's some more stuff that you can do. I recommend not really working on Chapter 10 until after you take the midterm. By the way, Chapter 10 is not on the midterm. The midterm covers up to Chapter 9. So, but you still have to do Chapter 10 later next week. So Thursday might be a good day to work on Chapter 10. Okay. You'll also notice, and this is not a mistake, there is no discussion post, because I really want you to spend most of your time focusing on this test. So you don't have to worry about discussion post. You have enough to do next week. So sorry if you wanted to practice Chapter 10, but most people are happy that they get a little break on that. So I make the week a little easier in terms of new material. Any questions on that? Okay, let me show you one more piece under the course information. I think it's here. If you go to review applets and click on the link, you can go to practice true or false questions. Now, we don't want to check all of these because we haven't had them yet. When you take the final, when you're studying for the final, you want to check them all. But we've had descriptive statistics, probability, confidence interval, and hypothesis testing. If you submit, then it'll give you practice for the true falses. So that's more ways of practicing for the true false. So if the sample size is 100 and the population standard deviation is 20, then the standard deviation of the sampling distribution is 2. Is that clear? Is that true or not? True or false? What do you think? Get a 50-50. By the way, don't leave the true false blank. If you leave it blank, what's the probability of getting it right?
0.
0. If you guess and you have no idea, what's probability of getting it right?
50.
50%. Okay, don't be an idiot. 50% is better than 0%. So don't leave any of the true falses blank. And similarly, in all the work and every problem, anything left blank, I can't give you points for. So put in anything you might think is true on every problem. Does that make sense? Don't leave any problems blank. I can't give you points. I can't give you partial credit for blank stuff. So you think this is true or false?
True.
Think it's true? So let's click true. See that little smiley? That's what you want to see. But you also should read this. True by the central limit theorem, the standard deviation of the sampling distribution is the population standard deviation divided by the square root of the sample size. This is 20 over 10, which is equal to 2. Okay? There's hundreds of these, by the way. So you can practice lots of them. Any questions on this little helper for the true falses? Okay, so I recommend doing these until you just get them all right. Then or get most of them right at least. Then you'll be ready. If you don't practice, they might be pretty hard for you.
I just have a quick question. So are these true and false questions pretty similar to the old homework assignments? Because we can't access those. So like if we just do these ones.
Yeah, they're similar.
Okay.
They're not the same, but they're similar. I wrote them.
Okay.
And I wrote the ones on the old homework also. So you're going to see the same style of writing, because that's my style of writing. So I made this. Oh, by the way, this is made in JavaScript, which means that you can do it on your smartphone. It'll work. It should work, at least in theory. So if you're sitting around waiting for something and you got your smartphone out, just practice true falses. Okay, let me give you, and actually I forgot to grab it. You need a secret word. And the secret word is actually not a word. Wasn't last week either. If you remember. Remember last week was a number? So this week's secret word, there's not much room on this one. I'm gonna have to erase all this. There we go. The secret word is P. P for p-value. So in a way, it's a secret letter this time. Okay, so there's a secret word quiz, and hopefully one for you. So we're about done. We did an hour and a half. I think this is the longest webinar we've ever had. But I'll be happy. Let me stop the share. I'll be happy to answer any questions you might have about the midterm or about any of the topics we've covered or about anything else. It was a great time.
I just have a question. I mentioned it earlier on the Q&A form about the continuity corrections.
Yeah.
I know you said it's not going to be on there, but if I go through and do the problem, can I ask you if I did it right? That way I know I'm doing it right.
Yeah, but again, it won't be on the test, so I wouldn't waste your time on it.
Or just those problems at all won't be on the test? Because there was like
Continuity correction won't be on.
Okay.
Yeah, continuity correction. So if you use it or don't use it, I don't really care. I used to teach it. I'll tell you honestly, I used to teach it, and nobody ever got it right. It was just confusing, and I tried lots of different methods and explanations, and it didn't matter. So I gave up. And then I talked to my colleagues around the state, and they all had the same experience, and they're starting to give up also. So if you ever take graduate level stats class, it becomes important. But it's good enough we can get rid of it, and I don't feel guilty because other colleges have also gotten rid of it. So don't worry too much about that. There's just a little adjustment of 0.5. But students have a lot of trouble knowing which way to go, up or down. So I don't even do it anymore. I just stick with whatever the number is. Okay. So sorry if that's not quite the answer you wanted, but the idea is just don't stress about it. That will not, I promise you, that will not be part of the test.
Okay.
There could be confidence interval for proportions, but you don't need to use the continuity correction. Just do it. You're going to be using the calculator anyway. Okay, other questions?
For today's topic, I just wanted to clarify you can say that there's statistically significant evidence when the p-value is less than the level of significance.
Right.
So and like normally before this lecture we talked about level of significance as being like 95% or something.
Actually, that was a level of confidence.
Oh, okay.
Yeah. So we've changed the words just slightly.
Okay.
And it's kind of too bad, but I have to teach what's done. Does that make sense? I kind of I have to teach what everyone does, even though it's confusing.
Yeah.
But everyone in the world uses level of confidence for confidence intervals and level of significance for hypothesis testing, and they're like the flip side of the coin.
Okay.
Level of confidence is how confident you are you're right, and level of significance is how confident you are you're wrong. Do you see the difference?
Yeah, so that's why it's such a lower percentage.
Exactly. You want a low percent of being wrong and a high percent of being right. And the way they do confidence intervals, they talk about right, and hypothesis tests, they talk about wrong. I have no idea why. I've never heard anyone with a good explanation, but it's just what everyone does.
Okay, and then for this particular example that we did, it's 0.1 because of the type 2 error, right?
Right, the type 2 error was worse than the type 1 error.
Okay, so if type 1 was worse, then we would use 0.05 as a level of significance.
Then you'd use 0.01. 0.05 is if they're even.
Oh, but we use 0.1
if type 2 is worse.
And so that's okay.
So use 0.05 if they're about the same.
Okay.
You use 0.01 if type 1 is worse. You use 0.1 if type 2 is worse. And then if you're told what to use, you use what you're told what to do. Does that make sense?
Yeah.
So I'll let you know on the test next week, you'll be told what to use.
Okay, so we don't have to worry about interpreting which one's worse and then determining from that the level of significance.
You don't have to worry about for the test.
Okay.
For the project,
okay.
You do have to worry about it.
Okay.
Does that make sense?
Yes.
Yeah, there's only so much I can ask you to write out because otherwise it gets really long on the test. But on the project, I can ask you to write 10 pages. Do you see how that works?
Yeah. Okay.
But on the test, I can't do that because you only have a couple hours.
Okay.
Okay, other questions? But that was a really important question, is understanding P versus alpha. And the idea that P is really small, then you say it's such a small chance to get what we got that something went wrong. And what went wrong was the assumption of H naught. Do you see that? Whereas as P is large, you say, well, the chance isn't that small, so why would we think something went wrong? Do you see? H naught could have been true.
Okay.
Does that make sense?
Kinda, yeah.
If not, let me give you this example. It's what I do with my other class when I have a little more time. But let's see, there it is. All right, see what I got here? Okay, so I'm gonna flip a coin, and here's the deal. If it's heads, you get $1. If it's tails, you pay $1. Does that sound fair?
Sure.
Okay, sounds like a fair game, doesn't it? But I might cheat. Okay, if I'm cheating, is it fair? Probably not, right? So you have to decide if you're going to say that I'm cheating or not. Do you see that?
Okay.
So I'm going to flip a bunch of coins, and you tell me if you think I'm cheating. All right?
Okay.
I just got tails. Guess who won?
viewed it, or
I did.
okay?
Okay.
I see it.
All right. With one coin flip, do you really think I'm cheating just because I got one tails?
No.
No, you're not. You can't say he's cheating because that's a 50% chance. Does that make sense?
Mm-hmm.
Okay. I just got another tails. Okay. Now you might be getting a little bit more worried, but that's still a 25% chance. That could happen, right?
Yeah.
Okay. All right. I just got another tails. Is your worrying getting more?
Yes.
Okay, so that's 12.5% chance. Okay, you're worried, but you're not convinced I'm cheating, right? You're not ready to do like a formal accusation and send me to jail, right? Does that make sense?
Mm-hmm.
But what if I flipped 50 times and got 49 tails?
Then I'd be worried that you're cheating.
You accuse me, not just worried, but you would accuse me. You would
Okay.
say you have the evidence. Do you see that?
Okay.
49 tails shouldn't happen. Big red flag, because the p-value, the probability of that happening, is so low that it's time to say that you are right about you're worrying about me cheating. Do you see that?
Okay.
But if it was just 2 coin flips and it was 25%, then the p-value is 0.25. It's not low enough yet to do formal accusations.
Okay.
And that's why a low p-value, you're able to say you're basically accusing H naught of being wrong.
Okay.
Whereas if the p-value is high, then you don't have that evidence to accuse H naught of being wrong. Is that clear? Does that help a little more?
Yeah. Yeah, definitely. Okay.
Other questions? But it's a good one because that's really important to understand what the p-value is about. And it's that probability that if I wasn't cheating, that I would get so many tails. Do you see that? And if that probability is really small, then you say that he's cheating. Then you say there's statistically significant evidence. If the p-value is, say, just 0.25, you don't say I'm not cheating. You just don't have enough evidence to accuse me yet. Do you see how that works?
Yeah. Okay.
Any other questions? But very good question, Dominique. Any other questions? Okay, if there aren't any questions, we can say goodnight, but if you have, I can answer them.
I have one more about the
Okay.
midterm. Sorry. For just all the stuff in that week 10 module or week 8 module, next week's module, is that going to be, do you like recommend going through all the practice problems and all that? And do you think that's like the best way to study for this?
Yeah, one thing I definitely recommend is looking at, say, problem number 1. Finding about 3 or 4 problems that are like that and do them. Write them out. Don't just do them in your head. Literally write them out. And then if there's some that you don't know how to do, and you can even, if you have you're in San Francisco, so you may not know anyone in San Francisco that's taken the class, but you can make some up for yourself. That was my secret to success, by the way. I used to write a test for myself when I was a student. And if I could do that and then get it right, then I'd probably be ready. Does that make sense? And then I did really well.
Okay.
So write out some problems, and again, you can find them on the assignments. You can go to the review mode and look at the assignments.
Okay.
And
so you can't do them, but you can look at the like wording.
Yeah, and then you can try doing the problems.
Okay.
Does that make sense? But make sure you write them out. Don't do them like on the computer where you just have to type in a number. Does that make sense?
Yeah.
Like on confidence interval, you just clicked which of the 4 were right for the explanation. Don't do that. Write out the explanation. Do you see the difference?
Yeah.
And do as many as you need to do until it's busy work. If you're still thinking as you're doing them, you're not ready yet. If it's busy work, then go on to the next type. Okay, and again, on Canvas, you can find the structure, so you know all the different types you're going to get. I kept a few that are a little vague, like something with statistics, mean, standard deviation, z-score, etc.
Okay.
But most of them are pretty. They show it pretty well.
Okay.
Any other questions? Again, if not, we can say goodnight. Or if you have, I can answer questions.
Good night. Thank you.
Okay, good night.
All right.
And good night. And for all of you watching this as an archived webinar, thanks for watching. Please post on the Q&A forum. If you have any questions about anything, I'll be happy to answer. Have a good night.